Today we're making a drawing robot. I'm Mr. Pratt and I've been teaching robotics students for over 10 years now. And today you're going to learn how you can build a very simple rover in about 10 minutes, add a pen to this, and then learn how to program this rover using Python to be able to draw a bunch of different shapes and learn about loops in the process. First thing you're going to need is you're going to need one of my 3D printed boards here. I've got a Metro M4, but an Arduino also fits on top. I'm going to have all these 3D printed files down below. I would suggest you have some sort of alternative servo power delivery. This is what I have set up here. It's got a little UBEC. I've got a video down below, but effectively this will allow you to power up to 8 servos in your project. You're going to need a couple rotational servos. This just allows you to take any standard servo and mesh it out to a Technic axle. And the last thing you're going to need is a couple battery packs. I've got a 9-volt battery pack here and then a 6-volt battery pack. And of course, the last thing you're going to need is one of your old school EV3 or NXT kits. First thing I'm going to do is I'm going to grab my servo mount here, and I am going to load it up with a bunch of black pins here. The more black pins you put in here, the better, because it makes it less likely for your servo to fall off. Sometimes you can push in the bottom of the table, and that helps you fit it in. And then on this one, I'm actually going to run the cable facing forwards, and the cable facing out this way, so that I can mount up on this side of the microcontroller. Now, this is key because our wheel output's actually going to go here eventually. And we need our power output to be facing away because we're going to put a big brick here. So if you put this barrel jack on this side, you will not be able to plug anything into power. So let's do the same thing on the other side. I'm going to make sure that my points are mirrored. So I make sure that both of my cables are running backwards here. I'm going to put another 4 pins in. I like to give it a little push on the table just to make sure all my pins are seated. Again, make sure that they are running mirrored to each other. That's looking pretty good. Oh, my board has fallen off. All right, so we're ready to keep going. Now on one side, I'm going to throw in a 3-length axle. And I'm going to put another 3-length axle on the other side. You may find that pushing it on the table helps you get a little bit more force to be able to get those axles all the way in. You also take a small hammer, anything like that would work. Now, next to this, we're going to put on a 24-tooth gear on top of that point. And we're going to run our wheels out the back here. So I'm going to grab 2 6-length axles, run them in on this side to the second last hole. Again, in the second last hole, we're going to throw another 24 tooth on that for both sides. Okay. And then we need some way to make sure this doesn't fall off. So to do that, we're going to use one of these kind of angled brackets and a couple 3-length beams. So I'm going to throw in a cross connector. Actually, on this one, I'm going to do 2 black. No, I need to do 2 3-length beams here. Sorry, not cross connector. 3-length. Run our 3-length hole like so. And then we can mount it on so that it mounts into our frame like that. We'll do the same thing on the other side. I guess technically you don't need a 3-length on the top part. You only need a black hole on the top part. Run our 3-length beam through again. Oh, I built that one backwards. I'll run it through on this side actually. Run it through so that we're not through the center point. Click in, and that should hold our wheel on nice. Now let's get 2 wheels on. The wheel you choose doesn't really matter. I'm going to choose this wheel. Now, before we mount this, we need another 3-length beam, because if we mount this wheel on, you're going to find that it's just going to rub against your surface. So we're going to grab a couple black and a couple blue with an axle connectors. We're going to throw the axle connector side on this, the very end, as well as our other point, and throw our 3-length beam on. And then this tire has a shallow side and a deep side. I'm going to throw the shallow side against the robot, because what that allows me to do is, now you notice there's just enough clearance that this 3-wheel provides that this wheel is not actually going to scrub against this joint. And now we should have a nice point. You're welcome to put a bushing on this if you think that this might come off. I generally do. Makes life a little easier. We'll repeat the same thing on this side. And put in another blue, another black, a 3-length beam. Grab yourself another tire, pop it on, and one more bushing, in like so. And that's the first part set up. We've got our wheels ready to rock. The next task for us is to get our battery packs set up. So I'm actually going to mount the batteries inside now. I'm going to take one, slide it through, make sure that the cable runs out this side. I'm going to throw on another couple pins. Keep this together. I'm going to throw a couple in the middle here too, just to get us a really nice stable connection. Going to sandwich my other battery pack on top. And again, make sure that our points line up like so. And then sandwich these two together, so I have a nice strong battery box. It's not going to be coming undone on me here. Next thing, I'm going to load up our pins here so that we can connect it to this far side. Now the one thing I want to make sure is that on my design, some of these pins don't actually line up, because sometimes people like to do different designs here. So I'm going to put 1, 2, 3 on this side and 1, 2, 3 on this side. I'm going to skip that middle hole. Again, you might find that pushing this thing down on a table helps you seat those pins properly. And I'm going to make sure that I line this. Oh, that one just got crushed. I'm just going to take that one out. And then I'm going to line it up so that we mount our point on. Now we need some way of stopping this thing from falling to the ground. So for that, I'm going to use a ball caster. And on this ball caster, I'm going to take one of these 90-degree connectors, push it in like so, push another one up on the top. I've got a little sub-assembly here. I'm going to mount this one in the middle up top so that we've got our joints sliding around, ready to go. Now, the last thing we need for a robot is our servo power delivery module. This is going to allow us to get power to our servos. You want to make sure that your power output is on the same side as the outputs for your battery cables. So I'm going to go ahead and throw 4 pins in here. And then slide it in up top like so. Just push mine off. There we go. And then let's wire everything up. So I'm going to grab my 9-volt battery pack, connect that to my servo power delivery board. Grab the 6-volt battery pack, connect that to my Metro board. On my servos, I'm going to route this up through the middle. And then you can choose yourself a servo port. I'm going to make sure that I connect my servo cable to the servo side here, like so. I'm going to choose port 2. And then same thing. Connect it in. And then I need to actually connect my servos. So I'm going to do a common ground on this far side. You can choose any ground port you want on the far side. Let's zoom in a little bit so you can see that. You can choose any ground port connected back to your common ground on your Metro controller board. I'm going to choose my common ground back there. And then you can choose any digital pins you want. I'm going to choose digital 0. Actually, sorry, because I have it on 2 and 3, it doesn't really matter. But just for my own sanity, I'm going to choose digital 2 and 3, just so that it's easy, so that I know where my servos line up to. Again, that doesn't actually matter, but it's a little neater for wiring. Now we're going to add our drawing tool, and in our drawing tool, what I've done is I've got a simple little 3D model here. It's a Technic compatible pen holder. I'll leave the STL file down below if you need this. And it's just got a little M4 bolt here that'll be able to hold this in to be able to hold your pen. It's got a nice little clamp here, and as you squeeze this in, it squeezes the pen. If you want to have exact perfect sections, you need to have this directly in the middle of your center of rotation. And the center of rotation is in the middle of your two motors, so my case would be right here, but I'm actually liking the patterns that it looks when I have a little bit of offset rotation. I've just added a little expansion piece here that allows me to simply take this piece and raise it up a bit so that I can put this in the middle of my robot, like so. Now the last thing you're going to want to do once you have the lid off is you need to calibrate your heights so that when this thing rests down, your pen is pushing off the table, but not pushing off the table so much that this is happening, where now I'm actually lifting my table off. And once I've got my pen on, now I can go about actually calibrating my forwards and my turns. So let's get started with some simple code for this. We're gonna have to do some import libraries first. We're gonna import time as always. We're gonna, import board. We're gonna import PWM IO. And we're going to say from Adafruit motor, Adafruit underscore motor, import servo. If you don't have this library on your CircuitPython device, make sure it's in the lib folder on your CircuitPy drive. If you don't have this, I'll leave the link to it in the GitHub link down below. Next, at the start of my code, I always like to give myself a pinout. And this basically lets me know where certain things are connected. So I can say that the left servo is D0 and the right servo is D1. This just gives me a bit of a reference so that I know where I physically plug things into my robot. Next, I'll add in a little comment here, and I'm going to say init servos, so that this section of our code is going to be for the initialization of our servo motors. And how we initialize servo motors in Python is the first thing we have to do is we have to create a PWM object, PWM.io.pwmout. And we'll initialize our left servo first, and our frequency is equal to 50. And we'll do the same thing for a second PWM object, but this time it's going to be PWM1. So that creates a pulse width modulation object, but now we need to actually say this is an instance of a servo object. So now I'm going to go ahead and say left servo equal to servo.continuous servo. And we're going to call our left PWM object. And we're going to do the same thing with the right servo is equal to servo.continuous servo PWM2. So now we've got our servos created. Let's go ahead and start making some functions. We're going to need a couple ones. We're going to need a function for turning, a function for stopping, and a function for going forwards. So I'm going to go ahead and say functions. And let's define a new function called stop. We're not going to give this function any arguments. And our stop is simply going to print a stop value so that we know when we're running into this function. We're going to say left servo dot throttle is going to be equal to 0 because the 0 value is going to stop it. And the same thing, we're going to do a right servo dot throttle is going to be equal to 0. And this will just simply stop, and then I'm going to stop for a certain number of time. I might say time.sleep, and I might sleep for 1 second every single time that I ask the rover to stop. Now let's create our forward function here. So I'm going to say define forward open parentheses, and I'm going to give it a argument or a parameter called sleep time. The reason I'm going to give it this is I'd like to be able to go forward in my drawing program for a non-discrete amount of time. I want to be able to choose how long I go forward for, and putting that inside of our function is going to make it really, really easy. Because what's going to happen is when we call our function, we can give this sleep time a different number, and we're going to move forward for a different number of seconds or a different fraction of a second whenever we call it. So for this, we're going to simply print forward. We'll grab both of our servos again. And now comes the time for you to do some calibration. You need to figure out what values both of your servos need to be at in order for you to actually go. So because of our orientation, 1 is going to be negative and 1 is going to be positive. You can do any value between 0 or -1 and 1. What we're going to do now is we're actually going to calibrate this straight state or this forward state. So now I've defined my stop function, my forward function, and now I'm going to go ahead and just call forward, and let's see if that's calibrated correctly. I've got a big sheet of paper here that I'm just going to tape down. You want to make sure you tape down your surface, because otherwise your rover is going to want to try to draw on it, and that's going to make life a little bit difficult. I like to put my drawing pen on the surface so that I know when I'm going straight. I'm going to push reset, turn on my power, and then we'll see if we're actually going to be drawing straight. All right. Let's try that again. Push reset. And if we move this out of the way, I've actually got a pretty straight line. That's the most important thing for here. The turning, not so much, but this straight line is the most important thing here. So let's move on to the turns. So thankfully mine was calibrated correctly. If you find you're drifting one side or the other, you may need to increase one side or decrease the other side to be able to have yourself a more accurate point. Let's do the same thing with turning now. Let's go ahead and define a turn function, and I'm going to create a sleep time. Same thing. I'm going to print turning, and I'm going to go ahead and put in my 2 throttle values here. Now for my turn, I'm going to add a few new lines so we can see this. For my turn, I'm actually going to have both of them go the same positive value. And because they're both going positive, that's going to spin them in opposite directions, and then we should pivot in place. So just like we did with the forward, let's go ahead and call turn, maybe for 0.3 seconds, a stop rover. We're going to call a forward for maybe 1 second, and then a turn for 1.5 seconds, just to see what that looks like. So let's go see what some of these turning calibrations do. Push reset, flick on my power. I should have a small turn, followed by forward, and then a big turn. So we see that depending on how much we turn, it makes different shapes. So it's up to you to decide how much you want to turn to be able to make different tessellations. Now let's take a look if we were to take these and go forward turn, forward turn, forward turn, forward turn, and repeat this a whole bunch of times to see what kind of different shapes we can make. So as you're doing these calibrations, you may find it handy to have some defined variables for this. You might want to say turn 90 is equal to 0.75 seconds, or yours may be different, maybe 0.6. You may want to have a few different, say turn 45 degrees equals 0.4 seconds. I'm not actually sure how much this is going to be, but defining a few variables that you can have specific sections where you're going to turn is going to be really, really helpful for that. So the last thing we're going to do is actually create some drawings. So let's try to draw a square shape for the most part. Because we're not directly in the center, it's not actually going to make a perfect square, but we'll go through that. To be able to do that, we're going to use a loop. What we could say is we could type in turn, and then we're going to call the turn 90, and then stop, and then forward for 1 second, and then call a stop again, and then copy and paste that 4 times. We don't want to have to copy and paste that 4 times. The nice thing about using robots is that we can loop this through. So in Python, there's a really easy loop that you can use to repeat actions. So I'm going to say for I in range, open parentheses, and then 4, colon. I'll grab all these and I'll press tab to indent it inside. And what this is going to do is it's basically going to repeat whatever code is indented inside 4 times. If I were to say do this 50 times, it's going to repeat it 50 times. And that's a really simple loop that we can do. So let's go ahead and draw this and see what comes out of it. flick on our motor power, restart our board, and let's see what kind of shapes we make. You can see with this shape, because our pen is not directly in the center of our rotation point, we end up getting this kind of cool twist out pattern, because you can see just about how far off we are from the center rotation. If we would want to do this, we would just simply have to move this pen to be directly between your two center points, which your center rotation would be right about here. Because of my design, I can't get a pen directly in there. But if you were to take your pen mounted directly in the middle of your two wheels, you would have a perfect square. So now you can practice make some even more creative shapes. You might say turn 50 times, turn 0.3, and then maybe move only forward for half, and see what that comes up with. You could turn more than 90 degrees. You could stop for 1.5 seconds. You could turn for 2 full seconds to be able to see what kind of different shapes you can make. So I hope you found that helpful as a tutorial, and best of luck with making some different drawings with your robot.